Welcome to the Deep Dive with Farmtips Diary. Today we explore how solar farms are being redesigned for the future of farming. Places where machines, not just crops, move in harmony with sunlight. This is the story of how agriculture is merging with robotics and renewable energy, transforming open land into intelligent ecosystems that feed us, power us, and run themselves. In this deep dive, we will uncover how to design solar systems without blocking tractors or drones, explore the rise of robot-ready farms, and understand how agrivoltaics now supports both crops and automation. We will look at real-world examples and reveal how optimizing layout design can create the perfect balance between energy and productivity. The clash between panels and plows. When solar energy first entered the agricultural world, it was seen as a promising way to lower costs and reduce carbon footprints. But a new problem quickly emerged. Traditional solar installations were not designed with tractors or harvesters in mind. Rows of panels fixed close to the ground made maneuvering large machinery difficult. In many cases, panels had to be built on land that could otherwise grow crops. For decades, farmers and engineers were locked in a quiet struggle: how to capture sunlight without losing valuable arable land. Then came automation. A wave of machines, from driverless tractors to AI-powered weeders, that need wide, accessible, and intelligently structured landscapes to operate effectively. The challenge was clear. How do you build a solar farm that lets both light and machines pass through freely? The answer arrived in the form of a concept called the machine-friendly solar site. What makes a solar site machine-friendly? A machine-friendly solar site is designed with two goals in mind: maximizing energy production and maintaining smooth agricultural operations. It is the meeting point between electrical engineering, robotics, and field management. Imagine solar panels elevated above crops, allowing machines to drive directly underneath. Rows are spaced widely enough for autonomous tractors to pass, yet positioned to capture optimal sunlight. Sensors are embedded in the soil, tracking both crop conditions and energy performance in real time. The key principle is integration, not separation. Instead of solar panels replacing crops, they now coexist. Instead of machinery avoiding solar zones, they navigate through them seamlessly. To achieve this, several design factors come into play. The first is panel height. Panels must be elevated anywhere from 2 to 5 meters depending on the type of machinery used. This gives robots, drones, and tractors enough clearance to move freely. The second factor is row spacing and alignment. Engineers use advanced modeling software to simulate both sunlight angles and vehicle paths. A properly optimized design allows autonomous vehicles to navigate with centimeter-level precision while minimizing shading on crops. Finally, ground surfaces are reinforced with materials that prevent soil erosion and provide stable footing for machines even during wet seasons. Some farms even use light-permeable solar panels that allow filtered sunlight to reach the ground, creating a gentle microclimate beneath. This careful choreography of technology and terrain allows farmers to produce both electricity and food without compromise. The rise of robot-ready farms automation has already begun to redefine how we think about farming. From seed planting to pest control, autonomous machines are taking over repetitive and precision-demanding tasks, but they require an environment tailored to their needs, one that combines spatial freedom, connectivity, and data infrastructure. In a robot-ready solar farm, the entire system becomes a synchronized network. Drones monitor crop health from above, ground robots analyze soil conditions. Tractors equipped with GPS and machine learning navigate between solar panel rows to plant or harvest with perfect accuracy. Each device communicates through a shared digital framework known as the farm operating system. This cloud-based control center integrates data from sensors, cameras, and solar management systems. The result is a farm that continuously learns, adjusts, and optimizes itself. Solar power fuels this entire ecosystem. During daylight hours, electricity from the panels charges batteries that run drones, sensors, and automated vehicles. Excess power is stored or sold back to the grid. When machines return to charging stations, they are powered entirely by renewable energy. In essence, sunlight has become the new fuel for machines, harvested, stored, and distributed through an intelligent energy web that keeps the entire farm alive. Designing for dual use: crops and power. The art of dual-use farming, also known as agrivoltaics, is the practice of combining agricultural production with solar energy generation on the same land. When designed correctly, both systems can support and enhance each other. At first glance, placing solar panels over crops may seem counterproductive. Crops need light, and panels block it. but research has shown that some plants actually thrive under partial shading, especially in hot or dry climates. Vegetables like lettuce, spinach, and peppers grow better when shielded from intense midday sun. The panels also protect soil moisture, reducing evaporation and water demand. Beneath them, humidity levels stay higher, and temperatures remain more stable, a quiet climate advantage that strengthens resilience against heat waves and droughts. Meanwhile, solar panels themselves operate more efficiently when slightly cooler, meaning the crops below indirectly help improve energy production. It is a beautifully circular relationship where one element supports the other. When robotics enter the picture, this synergy deepens. Machines can navigate the shaded areas to perform weeding, harvesting, and soil analysis without human fatigue or error. This merging of plant biology, renewable energy, and automation represents the new frontier of sustainable productivity. Smart infrastructure for modern farms. The backbone of every machine-friendly solar site is its infrastructure. This includes not just panels and tractors, but everything that connects them, from fiber optic lines to charging docks and sensor grids. Autonomous vehicles rely on real-time positioning systems that use both GPS and local beacons for centimeter precision. This allows them to move in perfectly straight lines, even between narrow rows of panels. Drones complement them by scanning aerial maps that guide adjustments in real time. Charging infrastructure is equally important. Some farms install solar-powered charging stations where robots dock between shifts, pulling energy directly from the panels. Others integrate mobile battery trailers that deliver power to remote field corners, keeping machines operational throughout the day. Connectivity is another key. Machine-friendly farms use local networks to keep devices in constant communication. A central control hub gathers all the data, analyzes it with AI, and sends optimized instructions back to every machine and energy unit. This web of sensors and software transforms the farm into a living organism that breathes information and light. Every action, from when to water to how to angle the panels, is guided by precise, data-driven feedback loops. The economics behind smart solar farms. Designing a robot-ready solar farm requires investment, but the economic potential is compelling. A traditional farm powered by the grid faces unpredictable electricity costs. Over time, these costs rise due to market volatility and global energy demand. By contrast, solar farms with on-site automation gain both cost control and revenue stability. Solar systems typically pay for themselves in 7 to 10 years through energy savings and power sales. Adding robotic automation increases upfront expenses but also dramatically improves efficiency. Robots can operate longer hours, reduce fuel consumption, and lower labor costs. Moreover, solar energy can offset the power required for robotics and processing equipment, effectively turning the farm into a circular energy system. For large-scale operations, the combined savings can reach tens of thousands of dollars annually. Governments are beginning to recognize this synergy. Many offer incentives for agrivoltaic projects and smart farming initiatives. These include grants for renewable installations, tax breaks for automation, and special financing for energy-efficient infrastructure. The farms that take advantage of these policies now will not only increase profits, but also position themselves as leaders in the next agricultural revolution. Real-world success stories across continents. A quiet transformation is underway. In Japan, researchers built an agrivoltaic rice field with elevated panels and autonomous water systems. The panels generate electricity for nearby communities, while shading the paddies during peak sunlight. AI algorithms monitor soil nutrients and adjust irrigation levels automatically. In France, vineyards have adopted solar tracking systems that tilt panels throughout the day, allowing both grapevines and harvesting robots to move freely underneath. The panels protect vines from frost while generating enough electricity to power cooling facilities and electric tractors. In the United States, a farm in California integrated solar arrays into a fully robotic orchard. Machines handle pruning, monitoring, and harvesting beneath elevated solar canopies. The system runs entirely on its own solar energy, reducing operational costs by nearly 40%. These examples illustrate a single truth. Farms that merge energy and automation are not futuristic concepts. They are operating today, proving that machine-friendly solar design is both practical and profitable. The environmental edge beyond economics? The environmental advantages are profound. Machine-friendly solar sites reduce carbon emissions by cutting reliance on fossil fuels for both electricity and machinery. They preserve soil by limiting compaction, since autonomous vehicles can follow precise routes instead of broad, repetitive tracks. By generating renewable power on-site, farms also contribute directly to decarbonizing rural infrastructure. Every kilowatt-hour produced locally reduces strain on distant power plants and transmission lines. Moreover, agrivoltaic layouts protect biodiversity. Shaded corridors under solar panels provide habitats for pollinators and soil organisms. Some farms plant native flowers or ground cover beneath the panels, creating ecosystems that enrich soil and attract beneficial insects. In the long run, combining renewable energy with automation could help farming become one of the most sustainable industries on the planet, reversing its reputation as a major source of emissions. Building the future of machine-integrated agriculture. As technology evolves, the next step is full synchronization. Future farms will use AI-driven layout design to plan not only where to plant, but where to drive, charge, and generate power. New panel materials will let more light pass through, opening opportunities for highlight crops. Autonomous vehicles will be smaller, lighter, and smarter, reducing the need for wide access paths. Instead of avoiding solar structures, they will collaborate with them, guided by shared algorithms that coordinate motion, sunlight, and soil health. Eventually, we might see networks of farms linked together, sharing data, power, and best practices. Each farm will operate as both a food source and a clean power station. Together, they will form a distributed energy landscape that supports rural economies and stabilizes power grids. This vision is not decades away. The foundation is already being laid by forward-thinking farmers and engineers who are building prototypes and refining techniques every season. Recap and reflection. In this deep dive, we explored how machine-friendly solar sites are rewriting the blueprint for modern farming. We saw how smart design enables both robots and crops to thrive, how agrivoltaics transforms sunlight into a shared resource, and how technology, when properly aligned, creates efficiency rather than disruption. The merging of automation and renewable energy marks a turning point in agricultural history. The field is no longer a static plot of land, but a dynamic, interconnected system, part machine, part organism, and fully alive with data and sunlight. If you found this exploration insightful, remember to like this video, share it with others, and subscribe to Farmtips Diary. Click the notification bell so you never miss a new deep dive. We hope this exploration has been valuable. Thanks for joining us on this deep dive. See you again on our next deep dive.